Okay, Unit 4 review. Consider the statement in a triangle. The altitudes, so we're going to be talking about the altitudes, are located within the triangle, so inside the triangle. Which of the following would serve as a counterexample? So this is something that's going to prove the statement false. If you look at page 71 of your notes, we have that there where we have the altitudes. A acute triangle has the orthocenter inside the triangle. The right triangle is on the triangle, and the obtuse triangle is the one that's going to be outside. So we're going to draw that where it's outside. This is an obtuse triangle. This segment is going to get extended till it's 90-degree angle. I extend it a little bit more. This one here is going to get extended till it makes a 90-degree angle, approximately. And then the angle here is my other altitude. So this is my orthocenter, and it is outside the triangle. So this is where they're located, outside the triangle, and the correct answer would be D. It says in a right triangle, the vertices are P, which is 0, 0, Q, which is 4, 4, R, 4, and 0. So we're going to go ahead and plot those points on a coordinate plane. Okay, so now that we have all 3 points plotted, it's asking you to find the equation of the perpendicular bisector of PQ. Well, here's PQ. Let me go ahead and draw the rest of the triangle. The perpendicular bisector, bisect means to cut in half equally, so this point would be the midpoint of PQ. And we're asking for a line that goes through it. So I can say this goes right 2, down 2, right 2, down 2, right 2, down 2. In the opposite direction, it could go up 2, left 2, up 2, left 2. So I'm only doing this so I can get a nice, pretty graph all the way through this triangle. Shade the triangle so you can see that. So now we have to find the equation of this line. It is going downward, so it's a negative slope. So I can automatically eliminate the 2 that are positive slopes. My slope, we said, was 2, 2, going negative. 2 over 2 makes that a negative 1. And my y-intercept is a point where it crosses the y-axis, which is 4. So using y equals mx plus b, we can see that y should be negative x plus 4, which makes the correct answer J. The next one, number 3, it says a right triangle has vertices P, Q, and R. So we're going to go ahead and take a coordinate plane and plot those points. Okay, now that the points are plotted, I'm going to go ahead and connect the sides. And the reason why I wanted to plot it is to find out which one would be the 90-degree angle. Well, Q is going to be my 90-degree angle. So if Q is my 90-degree angle, that means PR is my hypotenuse. And it's asking for the midpoint. Now, I can eyeball it and say it's approximately right there. And yeah, the coordinate of this one is 3 and 7. So yeah, it is D, but I want a more concrete answer, so I'm going to go ahead and use the midpoint formula also. So we're going to take the average of the x-coordinates. We're going to do a P, and R. The x-coordinate is negative 2 and 8, and the y-coordinate is 5 and 9. Doing my arithmetic also yields a 3, 7 as the point, which is what I got by observation. Number 4, if the triangles can be proved congruent using only the information marked on the diagram, what is the reason? Well, here I have a an angle, side, and an angle. So angle, side, angle. This one is 60, this is 70. This one's marked 50, this one's marked 70, so that means this one must be 60 by the triangle sum theorem. So I have the same thing, 60, 10, 70, 60, 10, 70. That is an angle, side, angle. That should be G. Now I did have an argument earlier that, well, this is also 50, then this must be 50. So could it not also be angle, angle, side? Well, yes, I guess it could be angle, angle, side, but based on what's given, it says information marked on the diagram. That is why we're going to go with angle, side, angle, because that said with the information marked. Okay, number 5. Which of the following statements are not necessarily true? An acute angle is an angle whose measure is, now this is incorrect, greater than 90. It should be less than, because an acute angle is less than 90. So this is a false statement. And it says in number 2, an obtuse angle is an angle whose measure is greater than 90 and less than 180. That is true for an obtuse angle, so I'll just move on. Number 3, if the sum of the measures of two angles that are supplementary is 180. Oh, sorry, it didn't say if, it said the sum of. The sum of two angles is 180. If it's supplementary, that's true. That's the definition of supplementary angles. Number 4, it says if two lines do not intersect, then they are parallel. This one's false. The other thing they could be is skew. Skew means that they're not parallel, they're not intersecting, and they're not on the same plane. So here's a three-dimensional figure. I'm going to draw a rectangular prism and draw my hidden lines. And two segments on this figure that would be skew would be this one here in the front plane, and then this one back here. Those two would be skew segments. So the correct answer there should have been C. Number 6, which of these pairs of triangles must be similar? Similarity. The definition of similarity is that angles will be congruent and sides are proportional. So letter F. Okay, where was I? Oh, an F. If two right triangles were the length, which of these pairs of triangles must be similar? Two right triangles where the length of each is 3. So this is an example where the hypotenuse is 3. They're both right triangles, but they do not look similar. So this would not be a choice I would choose. G, it says two acute triangles with two pairs of corresponding congruent sides. So here's an example of two triangles that have two pairs of congruent corresponding sides, but they're not similar. I would use my hands here as an example where my hands are the same length, but the distance between them can change. So this triangle that I'm making with my fingertips is very different from this triangle that I'm making now with my fingertips. So those two triangles I just made with my hands are not similar. Just because I have two side lengths that are the same doesn't mean that the triangles have to be the same. So no, it would not be similar. So I wouldn't select that one. H, two right triangles where one whose sides are in the ratio 3, 4, 5 and the other 5, 12, 13. Well, these are actually Pythagorean triples. And even though they satisfy the equation c squared equals a squared plus b squared, that doesn't necessarily make them similar triangles. Now for J, what you have is, so I wouldn't choose that one. So obviously I've narrowed it down to J, but let's explain why. It says two triangles, one with sides x, y, and z, and the other with sides 2x, 2y, 2z. What this is a dilation or an enlargement by 2. Now all of them are being changed by the same side. So this is an increasement, an enlargement, so yes, the triangles would be similar. They would be similar. Okay, on number 7, it says M and O has coordinates 0 and 2, 1, 0, and O, and I'm going to plot those points. Alright, so I went ahead and plotted the points, but I went ahead and spaced it out because it was getting kind of small, so I changed my scale to 0.5, 1, 1.52. So this is by 0.5, just so I could make the triangle bigger. This is the triangle M and O. It's asked what type of triangle is M and O. Well, in this case, the sides here are congruent, so it would be isosceles. If it was a right triangle, one of those angles would be 90. If it was scalene, all three of those sides would be different. And if it was equilateral, all three of those sides would have been equal. On number 8, it says, using the diagram, identify the dashed line segment. So what they did on this one is, using a compass, they put the sharp point on the vertex, they opened it to a certain length, and then drew an arc. From that arc, they moved the compass tip over here, and they drew this arc. They maintained that setting, moved the compass setting over here, and then drew this arc. Now the intersection of those two small arcs, they connected it to the vertex, and that is how they made an angle bisector. Number 9, a triangle has side lengths x, 3, and 7. What are the possible values of x? Well, using the triangle inequality theorem, it states that if you add the lengths of two sides of a triangle, it must be always greater than the third. Now there are 3 sides, so that means there's 3 different possibilities. Now I set it up by setting up the symbols and then filling it in diagonally. Now I go back, now that I have all three equations, I go back and actually solve these. I subtract 3, and x is going to be greater than 4. I collect my terms. This is 10. And this one becomes x is greater than -4 when I subtract it. Now once we have a negative value, we're going to go and cross that out because we're talking about side lengths, and in geometry we don't deal with negative values, so we're going to cross that one out. So this is a range, so this is going to be between 4 and 10. So anytime you have an in-between statement and and statement, then it's written in this fashion where the inequality symbols both point to the smallest value, when that case would have been C. Number 10, it says, isosceles triangle ABC has vertices A, B, and C. So I'm going to go ahead and plot those points. Okay, now that I have all three points plotted, I'm going to go ahead and connect them. And it says, what is the equation of the perpendicular bisector of AC? So this is the length of IC. I'm going to bisect it at this point, and I'm going to draw a perpendicular line that's going to go through point B, and it goes all the way through the y-axis at point 5, so that makes that equation y equals 5. It says, which of the following points is equidistant from A, which is -4, 1, and B, which is 2, -3. So we're going to plot those points. Okay, I went ahead and plotted all the points, including J, K, L, N, J, K, L, N. And it says points that are equidistant, so that's an important word, equal distances away from A and B. I can do process of elimination, say that N is closer to B than A, so N would not be an answer choice. Well, L is closer to B than A, so L would not be an answer choice. K is closer to A, so K would not be. So I'm assuming based on observation, J would be. But I can confirm my thought and count 1, 2, 3, 4, 5, and go up. 1, 2, 3, 4, 5 over 1. And go less 1. So yes, it is equal distances from. So the correct answer would be J. Point J, which is letter A. That would be the correct answer. Point J, which is letter A.
No, I mean like...
This one says, in an isosceles triangle, so I'm going to draw an isosceles triangle. Legs are marked congruent in an isosceles triangle. Two angles have equal measure, base angles. One of those angles is 36, so that means this one's 36. Which could be the measures of the other two angles in the triangle? Well, the measures of a triangle is 180. I take the difference of 36 and 36 from those, and I get 108. So it should be 36 and 108, which would have been F. Number 13. It says, in the figure shown, the measure of angle T is congruent to the measure of angle V. And E is the midpoint of TV. Well, I also know another thing by vertical angles. We also know that angle TER, this point here, will be congruent to angle CEV. So here we have an angle, a side, and an angle. So that's the ASA postulate. Angle, side, angle. In a right isosceles triangle, so here is an isosceles triangle, legs are congruent, 90-degree angle. It says the bisectors of angle A and B intersect at point F. So I'm going to draw an angle bisector and have it intersect at point F. Whoops. This is point F. It says, what is the measure of angle AFB? Well, AFB, here's point F, is just one part of this whole circle. Well, an entire circle is 360 degrees, and we're dividing this into 3 parts, so that gives me 120 degrees. Number 15 says, what is the measure of angle U? We need to solve for this triangle here. In order to find U, I need to find this point and this point. So I'm going to call this A. In order to find A, it's a linear pair, so I subtract 72 from 180, and I get 108. I need to find this one, which is also a linear pair with 145. So I subtract it from 145 from 180, and I get 35. And now in order to find angle U, the triangle sum theorem states that all three angles sum to equal 180. So I subtract the two parts that are known, and I get angle U is equal to 37 degrees. Okay, this one says a water company is stacking cylindrical pipes. Each has a diameter of 30 inches. That means from here to here is 30 inches, and half of that would be a radius, would be 15. When looked at from the end, the stacked pipes form a triangular pattern as shown here. When 10 pipes have been stacked up this way, what is the approximate height? I only have 6 pipes, so I need to add 4 more pipes. So I'm going to add 4 more pipes to the bottom here. 1, 2, oh, that's an ugly circle. 3, 4. I'm going to fix it. Okay, close enough. That's what I have. So what I'm looking at here, here's the center of this circle. I'm looking at this side length here. I'm going to darken it. This length down here. So it's a diameter and a radius. And then this, I'm going to call this X. It asks for the approximate height of the 10 pipes. So my height is actually going to be from this position all the way to this position. That is going to be my height. Now this I'm going to call X. I'm going to redraw this one right in here. I shade it so you can see which one I'm redrawing. This is the X I'm going to call from here to here. Now from this point to this point is a diameter. That's 30 inches. From this point to the center is a radius, which is half of 30, so that's 15. So this is going to give me 45 inches. Now I need to find the hypotenuse length. Here to here is 15. This is 30. Here to here is 30 and 15. So this is going to give me 90 units. I'm going to do Pythagorean theorem, which is a squared plus b squared equals c squared. And I get x squared plus 45 squared equals 90 squared. I'm going to subtract 45 squared and then take the square root. So I'm skipping a few steps here. And this gives me an approximate answer of 77.94. That's what that x is. Now, in order to find my height is this value of x, now plus 15. Okay, so the distance from here to here is x. And then from here to here is the radius, and we have 15. And here to here, we have another 15. So we need to add 30 to this value in order to get the height. Oops. Let me align that. So when we add 30 to this, I get the height is equal to 107.94 inches. And that's what we would bubble in on our test. That's it.